Yeah. And now we're going to hop into kind of a quick like break between the presentations. We're going to hop into a talk by Colin, as well as a bunch of really cool lightning talks by other Canadians. So you won't see mine and Byron's face nearly as much, which is probably a good break. But before we do that, I want to bring Derek on because I want to hop into some Q&A. We got some really good questions over the past couple sessions, and I want to make sure that we can address them as best as we can. So welcome back to the stage, Derek.
Hey, well done. I've been tracking it. I hope the folks watching this get a real sense of what was going on, right? We're deploying web apps on Vercel. We're connecting to our global infrastructure, NGS. We're also extending that, Byron's, own constellation of satellite instances. We're using Fly.io to deploy microservices. And as Jeremy and Byron have set out, those microservices can be deployed anywhere. And at the end, we actually saw it deployed as its own web app, right, inside of the demo app itself. And so the reason that we think this is so important is that regardless of NAT's ecosystem's role, we really do believe, as we approach 2 to 5 years out, all software will be designed like this. It will truly kind of be centrally managed, as you saw Byron kind of tweaking configs and tabs and server configs using a KV, but NATS allows this to be globally observable, regardless of deployment platform, regardless of cloud provider, edge provider, your own infrastructure, right, in stores and factories and web apps, as we talked about. And so we really believe that for us and the NATS IO ecosystem, which everyone on the conference is part of, that's kind of our North Star. That's kind of those assumptions that we test on a weekly basis of, do we really think this is where everything is going? And we really do believe that. And so as you see us present things, and as we're trying to evolve the technology and engage with all of our users and customers, it's specifically around, where do we think distributed systems are going? What are they going to need to look like to satisfy this velocity of innovation for organizations and companies? And so great job, by the way, Jeremy and Byron. I love it. Someone was commenting about live demos. There's always a risk there, but I believe in them deeply. We don't try to hide anything. We want to be very transparent with that. And I think we did a great job as Byron's computer locked up. We need to get him a new computer, I think. But yeah, it's incredibly powerful. We're incredibly proud of both the ecosystem and what we've built to date. But if anyone wants to have a takeaway moment, I really believe that we're such in the early phases of what this is going to look like. I really, really do. And so, excited about where we are, excited more about where I think we are going as not only an ecosystem and a technology, but broadly from a technology landscape. It's a fun time to be alive if you're a techno person, because there's so many compounding exponential technologies that are just going so fast, and it's hard for any of us to really realize what the future is going to look like, but we're trying to do our best.
Awesome. So we do have a lot of questions in the chat. I'm adding these to the screen right now. We're going to do our best to answer them. So we'll start with this one, and some of these were asked a while back, but that's fine. We'll address them one by one. The first one is: do you ever need to include identities like user IDs inside of subject names? Subject naming is tricky. Yes, it is. Many degrees of freedom and trade-offs. Would be great to get some more opinionated guidance. So, I have some high-level rules with them around this, but I know, Derek and a lot of the Canadians here have been working in messaging for many, many, many years. And so they probably have some wisdom to put there. But I like to really think about, what are some of the groups and hierarchies that you want to be able to organize around and to start naming your subjects off of that. The best kind of rule to keep in mind is that your subscribers don't really have to know the full subject, right? They can wildcard in a lot of instances, but your publishers do. Your publishers need to know exactly what they're publishing to, and so you're thinking through, your actual model of how your services or concepts communicate, and being able to figure out hierarchically how that works, and what actually would be useful inside of a subject that you can filter and key off of. Derek, I don't know if you have any really specific tips around, subject hierarchies and naming. I think that you mentioned the idea of Nats makes this a lot more adaptable than it was in the past, right?
Yeah. Yeah, I think there's, for folks that have been around in the messaging landscape, we probably all recall in the mid and late 90s sitting around for 2 weeks trying to define subject hierarchies. And what I think there's three things that I want to highlight here specific to this question. One is, Nats has true multi-tenancy, secure multi-tenancy. And as Jeremy and Byron were showing throughout the demo with some of the services and observability, was this notion of I can export certain things that I want to share with other accounts. What is really interesting, but maybe not as easy to understand, is that if Jeremy exports something and I import it into my world, my account, I dictate where that shows up. So he could have Jeremy's cool service, whatever, and I could say import it as foo. Meaning if I send something to foo, I'm getting an answer from Jeremy's service. Now, specifically to the question of, hey, how does Jeremy know that it's Derek's account or it's Derek as a user within that account? And those questions are really, really important for us. And where we get things that are interesting is how do we trust that, right? So Jeremy is not going to trust me. He wants to trust something about what that is. And so there's two things that we do today that we think are pretty powerful. When you actually do mappings or across exports and imports, you can tell the system, regardless of what Derek is saying or doing, map in his true account as understood by the system and deliver that to Jeremy as part of the subject. Very, very powerful construct. And if you notice what we do as a pattern on NGS, but this is applicable to any type of NATS deployment, is we have a service that looks exactly the same to everyone. It's called NGS usage. So you send a request to NGS usage, you give it like a time domain, 1 hour, 2 hours, whatever, and it reports back your usage, how many sessions, messages, whatever. But if you notice, it's exactly the same for everybody. Underneath the covers, let's say Byron is this NGS usage service. What he's actually receiving is ngs.usage.derek's account as trusted by the system, regardless of what I'm saying or not saying. And if you look at my account on NGS and say, hey, really explain to me what's going on, it's saying you only have permission to import, ngs.usage.derek's account, and you're mapping it to NGS usage. So for everybody, it looks the same. Now, in addition to that, and Jeremy actually showed this, and it might have gotten escaped. When you do this export-import stuff, so let's say Jeremy has an exported service and I import it. When I send a request to Jeremy, and he showed this, there's a consumer info header on every request that the system is actually validating and vouching for, regardless of what I'm saying. And by default, I don't share a lot, right? But I'll share kind of where I am, what account it's coming from, things like that. But if I wanted to, and I say, I really want the full Jeremy service experience, I can actually, when I import that service, say, I'm willing to share pretty much everything about myself. And when Jeremy gets that request, if he looks at, I think it's called client info header, and you can see these if you wanted to, it will tell me what version of the application I'm running, what language it's written in, what IP I'm connected to, what account, what user ID, everything under the sun. And it allows people to opt in or not to share a lot of data to enrich the service. Again, back to the original, the little opening that I gave around microservices being more personalized and being more relevant, and of course, being faster with latency stuff. And so, three high-level points is as you map services in, you can pick the subject. You can have the system automatically put the account, not the user right now, but the account into that subject space if you desire. And also all requests have a client info block, which by default shares just a little bit. But if you want, as the importing entity, you can say, no, I'm happy, I trust Jeremy, I trust Byron service, and share everything you want with them so that I can actually get a better experience.
Yeah, it reminds me a lot of, what people would typically experience in some modern API gateways, where you have an authorization step and that takes some API key that gets passed in as a bearer token or whatever. And then it's able to put more context, into the headers that get injected, that get proxied over. and you can trust that because you have your system that's managing those headers. I like that just comes for free with NATS. When you put imports and exports together, you get all that, because things like I'm writing an API that I want to be metered. I want a metered usage of like who's using it. You can do that, and you can trust that the whatever's being passed in the header is coming from the NATS system, which is really, really cool.
And I think we believe deeply in security and these notion of zero trust constructs. So even though Jeremy has given me permission to use his service, I might want to decide for myself whether or not I want to share a lot of information or just the bare minimum for him to actually service that request. And so by default, it's just the bare minimum, but you can opt in. And the good news is that for folks that know about Jetstream and know what Jetstream is in terms of that intelligent persistence layer inside of NATS, it uses all of these tricks already. So we're constantly building on these primitives all the time, and you can use them as well.
Awesome. All right, I'm going to move on to the next question, which I could probably answer pretty quickly. Is Helix aware of subject mapping of services? Like, can you compare latency, et cetera? Yeah, I mean, this is something I have in my head of what I want to do. But yeah, I want Helix to kind of be this idea of taking some of the core building blocks that exists in the NAT server and NATS clients and kind of put them together in interesting ways. And so you can kind of think of, a mixture of the subject mapping that Byron just put together, canary deployments, but mixing that with actual metrics collection and being able to kind of compare, and as you're rolling out a canary deployment, to make sure that there's no increased errors on that particularly new version and everything like that. So that, again, that's the type of tooling that it doesn't feel like it quite fits in like the core product of NATS. As much more higher level tooling, and that's the stuff that we want to be able to support as Synadia as we continue to support our customers. Yeah, it's great.
Yeah, and just so the folks on the call are clear, everything is possible with NATS. That was Jeremy's comment about our belief system around open core, which it can be successful, but to me it feels more like a different version of freemium enterprise, which no one really likes. But we do believe deeply in augment with a service, and so everything is possible with NATS, the open source project. What we're looking at doing is just trying to give a UX that makes some of these very complex and sophisticated behaviors, subject mapping and very sophisticated permissioning and sharing across accounts and across any type of topology, to be very accessible and simple.
Yep. Cool. Can you discuss the differences between mirrors and replicas really quick? And I'm assuming replicas meaning replication on a cluster level. Yeah.
Yeah. So when Byron was creating the original stream, and then he either created it with 3 replicas or he scaled it up, and you ask it, that system is considered a single system. And what happens is there's a consensus algorithm underneath the cover, such that when you send a message in, you're not going to get an acknowledgement back until a quorum of those servers that are hosting that asset agree. When you look at mirrors or sources, those things are asynchronously and self-healing kept in sync. So in other words, I will send the message in, I get an ACK back, which means that in that thing, however many replicas are running, a quorum of those have agreed and stamped that thing down on stable storage or memory. We allow both memory or file-based storage. Then they're replicated out to mirrors and sources.
Awesome. Yeah. So that replication is there for durability, whereas mirrors and sources are there for being able to, extend things out to the edge, to replicate in kind of a different use case.
It could be, but we've also seen folks that do, their data durability could maybe survive, let's say, accidentally getting a pub-ack, but maybe losing a little data on a catastrophic failure, but they want incredibly high ingest rates. So you could imagine very, very close, cluster, memory only, 200,000, 300,000, 400,000 ingest per second, and then they're mirrored out, meaning if something happens to that in memory only, 3-node system, hopefully there's not a blast radius of 1, but let's say there are, you actually have copies all around the world if you wanted to. So we give you a lot of power to match what your business demands are, from a data durability to business continuity.
Yeah. Typically you would have to pull a completely different technology off the shelf to try to accomplish those two very different things. Right. And it's cool to know that NATS can be flexible enough, depending on how you set up your streams and your topology, to be able to model either one of those use cases.
Yeah. And I think, what we've showcased today is this notion of Byron created one, and then he started creating mirrors on all of these leaf nodes that were running in his satellite, so to speak, constellation in fly.io. But one could imagine a world where, because NATS itself is inherently observable, right? Like we call it the matrix mode, or the fact that every single web app that was, for all the people participating, were getting all of the updates that Byron was doing. You could see a system where, since we have those base constructs, we could make this totally autonomous, such that, a request comes in on, let's say, from Japan, and the system is going, wow, this microservice is not running here, and the data it needs is not running here. And we will automatically reflect that based on some threshold modeling, but we'll start spinning these things up, which Byron was doing manually. But you can imagine a world very quickly, either from Snadia and NGS or within organizations, where this can be totally autonomous.
Mm-hmm. Somebody asked, KV is very cool for service configuration. Does a web interface exist to set and read keys? Does that already exist? We don't have an official web client for that, but it's easy enough to build one. I mean, I don't want to understate Byron's work that he did to put together this amazing demo, but I will say he hasn't been working weeks and weeks and weeks on this. I mean, Byron was able to put this together in a fairly short amount of time, using the WebSockets API, being able to talk back and forth to a KV. Even if you're just learning that, could still be an afternoon project, right? And I think that's the really fun part about all of this is there's not an official one that exists, but I'm sure we do have customers that have built them and that are using them in production. And so you could build a lot of really cool constructs on top of it.
Yeah, and even to add to that, Jeremy's work with Caddy Server, I was playing around a week ago or so with Dino, deploy. And so, similar to what Byron was doing, I didn't want to have any NATS code at all in what was running in the web. So I just used normal fetch operations due to a post, which then, running on the, I don't know what they call them in Dino deploy, but the TypeScript Dino service was also using what was running in the browser, and it could easily put stuff into streams or KVs or whatever you want. And that exercise literally took me about 20 minutes. I actually did the first version in the playground. So, and we're very deeply interested in this. We call it the last mile interface, right? The demo that Byron was doing is it's NATS code, right? That open source, WebSocket enabled things that are running inside of the web app. But we also realize that there's so much amazing tooling around some of the basic standards already. And so what does a world look like where the web app just has normal HTTP stuff, fetch, post, get, event sourcing or whatever like that, but is able to take advantage of the power of the NATS ecosystem like Byron and Jeremy were demoing today. And we think that that's going to be a really popular pattern.
Yep. All right, let's keep jamming through some of these because more and more questions keep pouring in, which is good. I think this is a good one to talk through. Is a mirror always read-only? Can you publish to it when you have lost the connection with the origin? I know we have a lot of opinions on this, and we had some explicit design decisions and some other things coming to kind of work through this use case in some interesting ways. So do you want to speak to this, Derek?
Yeah, so mirrors absolutely are, right? They're a bit-for-bit replica, sequence timestamping mechanisms and things like that. But remember, even day one of the launch of Jetstream, mirrors weren't the only construct for creating these replicas, digital twins. We have what's called sources. And sources can be, I can source from lots of different streams, but sources can also have their own subjects, meaning you can write to those individually. And so I know myself and Jeremy and Byron's been involved with different customers of ours around, active, east, west, for orders and failover and type stuff like that. And the key is if people on the conference are thinking about that, you're going to not use mirrors, you're going to use sources, right? And contact us. There's ways that we can do it, and we're trying to make it even easier to do that. We call it the active type of scenario. So mirrors are read only. If the origin server is not around and you try to do a publish or a KV put, that will fail. But we do have sources, which again, in addition to muxing and demuxing, can actually receive messages directly for themselves and replicate them back and forth. So you could imagine orders.east and an orders.west, and orders.west will sync over to here, but only pull orders.east over and vice versa. And then remember when Byron was doing that subject mapping, you could imagine a world where if you connect over here and you send to orders, you're sending to orders.west. If that falls away, you automatically reheal and get connected to east. And now over there, the mapping that's in place is orders goes to order.east.
So it sounds like there's flexibility in being able to set up kind of what you want here. If you want an active, if you want streams kind of act as read replicas, you can. We still, go back to the origin for specific writes. There's flexibility depending on what you want there. And I think that's something we want to be able to.
I just talked about, both of those are origins. You can send messages individually to those, even if the other side is down.
Yep. Great. I think this is very related, but I wanted to point out the kind of like leaf use cases. Can we mirror KVs, in both directions? I think you just talked about like using sources to be able to do that. And can we do this across like leaf node boundaries? And the answer is yes. And that's what makes it very powerful, is you can have these mirrors or source streams exist across leaf node boundaries and going in both directions.
You can even daisy chain them. So you could have an origin, a leaf node single mirror, and then have that replicated 5 times locally, let's say in a factory floor that's 6 million square feet, right? For very low latency access to data. That's important.
Yep. Very quickly, wondering what the difference is between a NAT server and a leaf node. The short answer I say is like a leaf node is a special connection that binds to, an account or a credential that kind of locks down essentially what traffic gets sent over that connection. And that leaf nodes and servers are different from clustering servers because it's not a single system, but a leaf node is a separate NAT system. So it has its own security domain and everything like that.
Yeah, to add to that though, so that everyone's on the same page, the executable, the binary server is exactly the same. You're downloading the exact same one. It's how the servers relate to each other that it becomes when you hear us talk about a leaf node server versus a cluster server versus a super cluster server. It's only about the relationships. The binary is exactly the same.
Yep. And those all break down to the different connection types, right? We have a client connection, gateway connection, cluster connection, leaf node connection. And the server intelligently manages those, differently.
Yeah, and I don't know if we've talked about it a lot, but for the folks that are more new to the NATS.io ecosystem, NAT servers themselves and all of the clients, I think we have 46 plus clients, they all self-heal themselves. So as connections go up and down, as it does in the big I internet, our system, that happens to us, and our systems are self-healing themselves. In addition, clients will self-heal. And in addition to that, clients, even if they have a DNS that maybe says, I know about Jeremy, when I connect to Jeremy and Byron's part of that cluster, my client automatically knows about Byron. And so we're actually also trying to not necessarily totally get rid of DNS. I'm a big fan of always blame DNS, but augment it. And so clients and servers are gossiping all the time about topology changes, meaning we want you to change the topology of these systems. We don't want it to be we're going to have a maintenance window for 2 hours, on Sunday night to upgrade the cluster. We don't think that's the way modern systems should work.
Great. Can we use key value buckets with a few million pupils? What's the limit to switching like something like Redis? And so, we can handle millions of keys. We have no problem doing that inside of a key value store. What is the limit to switching to I'm assuming it's what is the limit to switching away from something like Redis? And the main thing is that the NATS key value store does not have any kind of like value-based constructs in it. It's just a payload that you put in there. At the end of the day, this is all built on just Jetstream and persisting messages. So if you're closely tied to, push, pop, and all of the different kind of value-based semantics that are a part of Redis, you're not going to get those same things inside of Jetstream KV. You can kind of think of KV, much like kind of like Memcache was, where you just put in a key and you're able to extract value out of it. But where it gets interesting is being able to kind of really intricately replicate these things. You can't do that very easily with Redis, as well as a lot of the constructs around being able to kind of limit, who has access to what. And all of these really like elaborate authentication and authorization rules around it. And so I think those were the two things that kind of make Jetstream really interesting from this, because otherwise trying to configure Redis to do that is tough.
Yeah, and to add to what Jeremy's saying, I myself regularly on my home development box run hundreds of millions of keys. And we've had customers ask us to figure out a way to do billions and 10 billions of keys, which with enough hardware and memory you can do, but we're working very, very hard because we believe where we're going, especially in things like IoT and smart infrastructure, things that are tracking events, like the KVs are actually events for business logic, or metaverse online gaming, the number is going to be very, very big. So we are, very finely tuned as a company and an ecosystem around enabling that. But I regularly run hundreds of millions, pretty easily. It's not, it's not going to be perfect, but we are working at it. The other thing, and I think you'll get a little bit of this from one of the lightning talks, but we have the ability to, through that subject mapping construct, to transparently shard, so that the person is just saying, hey, update this KV, or I need this KV. And what's happening is that it's running across, let's say, 10 of these. And again, every one of these can be replicated individually, can have mirrors and sources and muxes. And so you can get pretty sophisticated with your backend topologies, but the clients still are pretty simple. They just go, update a key, get me a key. And they don't know all of the stuff that's going on, including as things are changing underneath the covers, right? As Byron was adding these mirrors, if you noticed, he wasn't saying, hold on, I have to restart everything and change everything. And we feel that that's a really important construct. Think of it like if someone was updating a cellular tower and we had to all reboot our phones. Some enterprise software kind of does that to you. And we believe deeply that the client should be very simple and they should be agnostic to any of the topology changes, either the core infrastructure, all the servers running around, or where the assets are, or how many digital twins and mirrors and sources they have.
Yep. I also had somebody, I had Jean Noel, who will be on here in a little bit, ping me and mention, I failed to mention that, Memcache doesn't have this concept of compare and set where KV does, which is very, very, a very common use case is somebody wants to be able to write to a key, but not overwrite something that doesn't already know about. And so we do support that construct as well. So you can kind of guarantee you're not, contending with writes in that way.
Yeah, I mean, he raises a great point because himself and of course Ari, who's very active in our ecosystem, anyone who's been on the Slack channel sees this, uses KVs as distributed locks and gating counting semaphores at a global scale. And that's because of that comparison mechanism.
Yep. Great. This is a quick one. I'll answer quickly. Can subject mappings be created dynamically? Yes. The way you do that is through accounts and mapping. So you can use the config file, but you'd want to, if you want to kind of do it dynamically, you write it to an account jot and push it to the server, and it automatically gets updated. Can a supercluster handle distributed IoT use case having 10 million devices connected and supporting subject-based routing from the cloud to a device? The short answer is yes. Like, these are problems that we are actively solving with customers right now, working out their topologies and their architectures and their subjects and how they want to communicate. But IoT is a perfect use case for this. And it gives us a lot of expandability going from a supercluster to possibly even like expanding those out into a further edge with leaf nodes. And so we're seeing a lot of really interesting bits there.
Yeah. So for example, to add to what Jeremy's saying, we're seeing especially in the smart infrastructure space, right? The multi-cloud, multi-geo, cloud-based services then extend into NAT servers and clusters running inside of factories and distribution centers, totally transparently. And then usually it's a higher level construct around business logic and things like that. But for those that are new to NATs, NATs can natively accept MQTT connections. And we see a lot of our customers now starting to pull in telemetry data from all of these sensors and devices on the factory floor to, again, enhance that business logic that they start with. I mean, NATS is becoming a central nervous system for a lot of our, large users and customers.
This is an interesting one. How should mobile clients connect to NATs? Does it make sense to connect them directly to a cluster or proxy request through a backend server? Does it depend on the use case? With Kafka, there's not a lot of options there, right?
Well, I mean, again, talking to what Byron just did, right? We don't have any load balancers. We don't have firewalls or VPNs. We still believe deeply in the security. So don't think you're giving up security to look at a NAS-based solution. But it depends on your use case. So if there's certain logic that you want to gate from an HTTP layer transitioning to, let's say, backend. For us, though, backend could be any cloud provider, any edge provider, any infrastructure. We support both. But in Byron's demo, he was just saying, hey, bring in the Nats, TypeScript code, run it, and create a WebSocket connection that automatically figures out the nearest server. It's automatically load balancing to the backend services. It's picking the geopin one that's closest to us. You kind of get all of that for free, but it's totally up to you.
Yep. For a mobile app, and it depends on what you're working with and everything like that. I think there's still plans to kind of flush out mobile clients in the future, but let's assume you're using our web sockets for a second. You get a lot out of the box in terms of authentication and authorization. And of course, it depends on your use case. I mean, if you're saying we want to have millions and millions of devices and we want them all to be consumers of a Jetstream, there's some real things to figure out there in terms of state and persistence, and there's a lot of variables that go into it. But core NATs, is totally fine. Like NAT servers handle millions of connections, no problem, and can send messages around. And so, just like we experienced today with the WebSockets on the web with Byron, you can theoretically do a lot of the same on mobile.
Yeah, and to Jeremy's point, we've been asked by a lot of customers to say, hey, we want to be able to have tens of millions or hundreds of millions or more observers of a persistent state. And obviously, what we're looking at there and what we're working with certain ecosystem users and customers is what we call a hybrid structure, which is there's this notion of a stream, a KB or whatever, and it can be told to republish events. And the republish events have enough information to understand if an endpoint is lost. But that observability point is just NAT's core. And to what Jeremy just said, we know that scales really, really well already.
Mm-hmm. I like this one. When you make a NATS only chat service where a backend only mints a JOT and NATS manages the real-time chat user's profile picture name would probably be part of the message payload. I think it got cut off. But yeah, I mean, there's this idea where it's just a JOT at the end of the day, and we really lean on the statelessness of a JOT. But you can imagine a backend service that mints it and includes, maybe OIDC related information on there as another claim. I think that works pretty well. And so, yeah, you can have your backend service kind of lean on NATs for all of the communication side and still put, some stateless info inside of that JOT. So, yeah, I love, one of my favorite things to do is to build front ends where I'm like, I have no backend except NATs. And I'm just going to lean on NATs for that. Turns out you could build a lot of stuff with that, not just web front ends, but like job services that are only use NATs, and all of our constructs around retries and exponential backoffs. And like, there's a lot of really fun things that you could build that ends up being pretty lightweight on the machinery because NATs takes care of a lot of it. Okay. This is a really interesting question. I don't even know the answer to it. But are there any plans for plugging other Jetstream persistence strategies beyond memory and file?
Yeah, I mean, obviously, those of folks who have been in the NATS.io ecosystem for a while probably know about Stan, NAT streaming, which did allow persistence through databases, type stuff. Right now, we have no plans for that. But one thing to keep in mind, we don't have any definitive plans to share today. But when you look at Jetstream as a core construct and say, wow, I can present a globally ordered set of messages. The interesting thing that pops up from that is that we don't have to necessarily represent the statement of record, meaning those messages can just be events that can be coming from an external data store. So what I mean by that is Jetstream has the ability today, if any external data store can be decomposed into a globally ordered sequence of events and state transitions, NGS and everything you've seen from Byron and Jeremy can be enacted on that data store. And so for Jetstream right now, I think we're still going to stick with file and memory, but stay tuned. You're going to see a lot more from us in terms of taking this core bedrock of connectivity and intelligent flow-based, Jetstream, and applying it to external data stores.
Awesome. Thanks so much for that rapid fire question answering, Derek. We're now out of time for our Q&A. We will be doing some more Q&A throughout, so feel free to ask questions and I'll pull stuff in that's relevant, especially for the presenters. But without further ado, Derek, Byron, thank you. I know, Byron, you're going to be coming on again pretty soon.